Hello, I am Debashish Purkayastha. I am the Vice Chair of Decode Working Group in MEC. I am also Principal Engineer in InterDigital. I am joined by my colleague Bob Gazda, who is also in InterDigital. We'll be discussing about MEC Sandbox and the recently held event Mech Hackathon, which was organized in association with Edge Computing World. In this presentation, we will first provide an overview of MEC Sandbox. Next, we will provide some highlights of the recently organized Mech Hackathon in association with Edge Computing World. Afterwards, we will provide a demo of the MEC Sandbox, and we will end this presentation with the plans for MEC Sandbox in 2022. The MEC Sandbox is an online edge emulation environment where edge application developers can experience and learn live MEC service APIs. The sandbox supplements open API specifications available in Etsy Forge. Sandbox user can remotely call MEC service endpoints from their edge application or edge environment. Alternatively, MEC services are also available through a web portal Try It Swagger interface, and user may interact with the MEC services from a web browser. The MEC Sandbox is available at trymechetsy.org. Before getting into the details of MEC services, let us discuss about the MEC system the sandbox emulates. The MEC Sandbox emulates an edge system set in Monaco. It offers user-selectable network topology configurations, which includes 4G, 5G, and Wi-Fi access points. For services, when MEC Sandbox was launched in January 2021, it offered MEC 12 Radio Network Information Service. It provides contextual information about the wireless conditions in the radio network. It also offered MEC 13 Location Service. It provides location information of the terminals that are in the system, and MEC 28 Wireless LAN Access Information Service, which provides wireless information for terminals in the wireless LAN access network. Later, in September 2021, two new services were added. First is MEC 11, which provides application and service enablement APIs. And the other one is the MEC 21, which is Application Mobility Service. It allows transferring the context of an edge application from one MEC platform to another. Before we dive into the demo, we would like to bring some of the highlights from the Mech Hackathon 2021 that was organized with Edge Computing World. The hackathon challenge was, what innovative edge application or service can you imagine using MEC service APIs? Developers were challenged to bring that application or service to life with the MEC Sandbox and the MEC services it offers. Teams were encouraged to be creative in selecting an application vertical to focus for their submission. There were a wide range of application verticals like autonomous drones, digital twins for robotics, video analysis or analytics, edge AI, support application for visually impaired. This hackathon was a global, fully virtual and remote event. Teams participated across the world, North America, Europe, and Asia. Teams were provided with a dedicated and isolated MEC Sandbox for their work, and the cost of participation was free. More information about the Edge Computing World, the Edge Developer Conference, can be found at this website. Mech Hackathon 2021 would not have been successful without all the supporters. Hackathon supporters include Etsy, Small Cell Forum. The industry supporters were Intel, Telefonica, Interdigital, and Equinix. Universities which supported the event were Carnegie Mellon University in the US and University Carlos III in Madrid, Spain. From the testbed point of view, Five Tonic in Spain, Empower with their EU and US offices, Power Project Office, which included Powder Testbed hosted at the University of Utah. The event was also supported by Open Edge Computing, and we cannot thank enough the event organizer, the Topio Network, without whom this event would not have been possible. Here's a great deal of thanks for all the supporters. The hackathon started on August 9th. Teams were provided with remote access and introduction to the sandbox. Sandbox instances and support was provided by Interdigital. Sandbox hosting was provided by Equinix. And optionally, any virtualization environment were provided on the Powder testbed hosted in the University of Utah. There was a mid-hackathon check-in submission on September 15th, and the final deliverable submission deadline was October 1st. The first round of judging happened between October 4th and 6th. This was a virtual remote event. 3 teams were shortlisted for hackathon pitches. These 3 teams presented in the Edge Developer Conference that was held on October 12th. And in that event, there was a panel of judges who made the final decision. The judges were Serge Fida from Empower, Bob Gazda from Interdigital, Dario Sabella from Intel. He is also the chair of ETSIMEC, and Satya from Carnegie Mellon University. The recording of these speeches can be found at the website of the event shown here. There were many great submissions from different teams, but the team that stood out from the rest was the A team, and their submission was Follow Mech. This was from Optare Solutions. Their submission was about an aerial camera drone which was onboarded with a Mech application for surveillance activities such as tracking pedestrians, wildlife control, and crowd control. The Mech application uses the resources of the Mech to execute the AI algorithms, and it will also use Mech services to adapt its behavior in response to the conditions such as coverage, signal quality, and power. A big round of applause for the winning team, the A team, Optare Solutions. Now we are going to switch gear and move into a demo of the MEC Sandbox. I'm going to turn over the presentation to my colleague, Bob Gazda. So Bob, please take it away.
Thank you very much, Debashish. I'm Bob Gazda from InterDigital, and it's my pleasure to present the MEC Sandbox. So first, where can you find the MEC Sandbox? As Debashish highlighted earlier, the Sandbox can be found at trymech.etsy.org. The Sandbox offers two sign-in options. One is with GitHub. Another is with GitLab via an Etsy online account. So these are the two authentication providers that the Sandbox uses for access. So you just need to choose one of these two. Then once you sign in, it'll bring up the MEC Sandbox portal, which we'll take a look at now. Okay, now that we are logged into the MEC Sandbox, before we take a look at how you interact with the service APIs, let's just do a quick tour of the user interface to get you familiar with it. First thing to point out is the map here on the left-hand side. This is the map of Monaco, and you can see the deployed edge network, edge system overlaid on the map, including this color coding for location zones. On the map, you see the points of access of the various cells and Wi-Fi access points in the network. You also see terminals and where they may be operating. Clicking on any one of these icons will show some more detailed information about that node. The map is also zoomable, so you can move in and move out to get greater levels of detail. There's also some customization that can be done. Over on the right-hand side is configuration controls. I can select between a set of network configurations here based on this pull down. I can add or remove UE devices from the system based on these controls for high velocity cars, low velocity pedestrians, or stationary terminals. And like I said, you can see more detailed information on each of these by clicking on the icon. I can pause mobility here, where it'll freeze mobility of terminals. That can be useful when, to get consistent query information from APIs or notifications. There are some controls here where I can create or delete application instance IDs for services that may need them, such as the service enablement and application enablement APIs in MEC 11. Now let's take a look at the bottom part of the user interface. Again, on the right-hand side, I have some controls where I can choose the MEC services that I may want to interact with. And there are two ways to interface with services. The first one at the bottom is a URL that I can utilize directly in my MEC application or MEC environment. I just need to copy it here. Or I can try it directly from the Sandbox UI in a Swagger interface, which I will take a look at here in 1 second. The final part of the UI is the API console, which you see here. The API console is going to show the messages and their details of all interactions between the services in the MEC Sandbox and their consumers. So let's select the location API, and I will open it up here in a new window. Let me shrink it a little bit so we can see both at the same time. So now I'm just going to make a simple query to show you how the system, how I can interact with services directly here from my browser. So I will issue the get query, and I'm just going to try it out. I'm just going to hit execute. I'm not adjusting any parameters. And I will get a response back. So here's the response from this query operation. The user query for location is providing the location of terminal devices in the network. And here you see 10.10.04 is this pedestrian moving within the system. At the time this call was made, this user was connected to 4G macro cell number 1. And you can see now here it's moved on to a small cell, 5G small cell. Last point to highlight is here in the API console, you see this same query has been issued. And if I go back, if I just click on this, that same information is appearing here. So this part of the MEC Sandbox interface is very helpful for when you are utilizing the sandbox from your own MEC application. You can visualize the contents of your calls. Final thing I would like to point out is the help here. So there's lots of helpful help information, especially the wiki, which has a detailed user guide. So we highly recommend that you check that out. Okay, to conclude the demonstration, just reiterating the help guide, where you can find useful information on the sandbox. There's the user guide on the Sandbox wiki. There's also a getting started webinar recording, which provides some helpful information. For anyone that is interested in the details of the MEC Sandbox implementation, the Sandbox specifications can be found on Etsy Forge at this link. There you can find details on the selection of endpoints within the MEC service APIs plus data model information. So it provides details about how the sandbox was developed. Finally, if there is anyone interested in edge emulation and further details about edge emulation, the Advantage Open Edge emulation platform from InterDigital is the emulation engine driving the MEC Sandbox. This is available in open source at the link that you can find here on GitHub. Advantage recently won the Small Cell Forum 2021 Award for Emerging Technology.
Thank you very much for the insightful and excellent demo. To close out, please check out the MEC Sandbox at trimech.etsy.org. The available MEC services are listed. The location APIs, the MEC 13, radio network information, MEC 12, wireless LAN access information, MEC 28, and this new MEC services, application service enablement APIs, MEC 11, and the application mobility service, MEC 21. Planned for 22, the bandwidth management and traffic steering services, MEC 15, UV application API, MEC 16, and the V2X API, MEC 30. Thank you very much for your time and attention. In addition to checking the MEC Sandbox, we encourage all to sign up and join the discussion on MEC Sandbox Slack space. That is a great place to connect with the Sandbox community and ask questions. Also, feel free to send me any questions directly to my email shown here. Thank you